This is a lesson on standard molar enthalpies of formation. Standard enthalpies of formation is the compound change in enthalpy that occurs when 1 mole of a compound is formed from elements. Standard states of compounds are the most stable at SATP. Formation reactions are always written for 1 mole of a particular product, which may be in any state or form, but the reactants elements must be in their standard states. Kilojoule per mole are the units that are used for formation of enthalpy. So delta H of an element is at its standard state is 0. The value 0 is assigned because the element is at its most fundamental form at standard conditions. These are some examples of standard enthalpy of formation for the compounds. These can be found on page 320 of the grade 12 chemistry textbook, or you can just go in the link in the description, so then you can see the full table of the compounds and what their delta H's equal. And you shouldn't have to remember the chart because it will be given to you when you're doing a quiz or a test. This is the equation that we use when we are solving molar enthalpies of formation. This sign here is the sum, so it represents the sum of all the enthalpy of formation in the compound. So this is the sum of all the products and then the sum of all the reactants. And a thing that is really important to remember that you are putting the products first and then you're subtracting the reactants. So you have all the products together and then you add them all up. And you do the same thing with all the reactants. You add all the reactants up and then you subtract the products and reactants. And then you get your delta H. So delta H is the standard molar enthalpy of formation, like I've said. So that's what the sign that we're using. And standard molar enthalpies of formation of an element that is already in its standard state is 0. So I have an example here. So delta H equals 0. So that means it's just by itself. The molecule is just singular. So like a carbon atom by itself, sodium, hydrogen, anything by itself, it is put as 0. The steps that are taken to solve for molar enthalpies of formation are: you want to make sure that the equation is balanced. If it's not already, they should be balanced, but it's a good habit to have. You want to use the table in the textbook or in the document to find the delta H of each molecule. You want to use the standard molar enthalpy of formation equation and then use the values that you've gotten from the table and plug those in where they need to be written. Write 1 mole of product in the state that is specified. Then you want to write the reactant elements in their standard states. You want to remember the diatomic elements, so hydrogen, oxygen, bromine, and iodine, and all of those. Then you want to choose the equation coefficients for the reactions to give a balanced equation yielding for 1 mole of product. Okay, so this is an example that I have for you guys to show you how you can solve for molar enthalpies. So the blue here is the reactants, and then the purple is the products, just so then you know which one is which and it's more clear so you guys can follow along better. And you got to remember that products are again subtracted by the reactants, so products first and then reactants. These are all of the compounds and what their kilojoule per mole equals. So this is just everything written out, how it will look like. So you have the number of moles and then your delta H, which you get from here, and you plug them in, so from the textbook. So yeah. So here is the equation all written out with their moles and the delta H's. So you got to remember that you want to cross out all the moles that you have here because you just want kilojoules at the end. So crossing out all of the moles for the products and the reactants. So then after you get that, you can add all the products together, and then you can add all the reactants together. So after adding them all up, the products, you get a value of negative 3,560.1 kilojoules, and then you're subtracting a negative 887.4 kilojoules. And when you have two negative numbers, or a negative number being subtracted, that will make it positive, which is important to remember when finding the value because that will affect what you get. So you gotta remember that negative equals positive. So after adding those two together, you get a delta H of negative 2,672.7 kilojoules. So this is the time to try it on your own. And here I've given you the equation again, just as a reminder that this is the sum of all enthalpies of the products, and then the sum of all the reactants, and the equation that I've given you. So you can use the link in the description or the textbook if you have it with you to find the delta H's and what they equal. Okay, so hopefully that went all right for everyone. So these are all what the delta H's equal, what the molecules equal. So this is everything written out. You have the products first, and then the reactants. And you cross out all the moles. And after you do that, you add all the products and all of the reactants together. And then you should get a negative 2,326 kilojoules for the products, and then you get a negative 105 kilojoules, and then you're subtracting, of course. So that here becomes positive. So then after you add those two together, you get a negative 2,221 kilojoules. So I'm just going to reiterate and tell you all again that it's really important to remember that you put in products first and then you're subtracting the reactants. And be careful at the end that you have kilojoules, not moles, because you're crossing out all the moles. So then you're just left with the amount of moles and then the kilojoules. And when it's negative and you're subtracting, that becomes a positive. I hope this helped everyone and you have a better grasp on how to find delta H from standard molar enthalpies.